Hi students, John here. Chapter 1 Application of Matrices and Determinant. Exercise 1.2. Example number 1.15. Find the rank of the following matrices. So first we know the rank of matrix denoted as row of A less than or equal to minimum of m comma n. M is row, n is column. Then by minor method in 3 by 3 matrix determinant of A does not equal to 0, then the rank of matrix row of A is 3. In case the determinant becomes 0, then the rank of matrix does not equal to 3. Next I'm going to check 2 by 2 matrix. The determinant value is does not equal to 0, then the rank becomes that order 2. In case the determinant value is equal to 0, the rank of matrix does not equal to 2, therefore rank of matrix is 1. First I am going to check the first subdivision. Consider A matrix is equal to 3 2 5 1 1 2 3 3 6. Here the matrix order becomes 3 rows 3 columns, so 3 by 3 matrix. Therefore the row of A less than or equal to minimum of m comma n can be written as 3 comma 3, which is equal to 3. So rank becomes 3 or less than or equal to 3. Okay, first I am going to find the determinant of A matrix, which is equal to determinant of 3 2 5 1 1 2 3 3 6. First I am going to give the symbol plus minus plus here, which is equal to, so 3 times of the determinant becomes 1 2 3 6, then minus 2 of row columns will be eliminated, then 1 3 2 6, then last one plus 5 can be written as rows and columns will be eliminated, so remaining entries 1 1 3 3, so which is equal to 3 times of first diagonal minus second diagonal. 1 6 are 6 minus 2 3s are 6, then minus 2 of first diagonal minus second diagonal. 1 6 are 6 minus 2 3s are 6, plus 5 1 3s are 3 minus 1 3s are 3, which is equal to 3 times of 0 minus 2 times of 6 minus 6 0, then plus 5 times of 3 minus 3 becomes 0, so answer becomes 0 minus 0 plus 0, which is equal to, so determinant value is equal to 0. So determinant of A is equal to 0 bina, then I'm going to check here row of A definitely does not equal to 3. Next I'm going to check in 2 by 2 minor matrix. So first I'm going to choose first 3 3 2 1 1 first minor matrix, which is equal to first diagonal minus second diagonal. 1 3s are 3 minus 1 2s are 2, which is equal to 1. Here the determinant value does not equal to 0, therefore in 2 by 2 matrix or the determinant value becomes something exists, then the row of matrix becomes 2. So next I am going to find the second subdivision. Consider as A matrix 4 3 1 minus 2 minus 3 minus 1 minus 2 4 6 7 minus 1 2 is a 3 rows 1 2 3 4 columns 3 by 4 matrix. Therefore the rank of matrix row of A less than or equal to minimum of 3 comma 4 is 3. So first I'm going to consider the first column, choose the 3 by 3 matrix. So in the formation or the matrix form. Okay, first I'm going to consider in 3 by 3 matrix. Okay, first one, the determinant of 4 minus 3 6, then 3 minus 1 7, 1 minus 2 minus 1, which is equal to plus minus plus. I'm going to give the symbol which is equal to, here 4 times of determinant value becomes minus 1 7 minus 2 minus 1, then minus 3 of the determinant becomes 3 oda rows and columns will be eliminated. Remaining entries -3, 6, -2, -1, then +1 oda determinant becomes rows and columns will be eliminated. So remaining -3, 6, -1, 7, which is 4 times of first diagonal minus second diagonal formation. So -1 into -1 becomes +1, minus of 7 into 2 becomes -14, then -3 of first diagonal minus second diagonal, minus into minus plus, so 1 into 3, 3, minus of 6 2s are 12, -12 plus 1 of first diagonal minus second diagonal, 3 into 7 becomes -21, then minus 1 into 6, -6, so then which is equal to 4 times of 1 plus 14 minus 3 times of 3 minus minus plus 12, then plus 1 of -21, minus into minus plus 6, which is equal to 4 of 15 minus 3 of 15, here plus 1 times of -21 plus 6 becomes -15, so which is equal to 4 5s are 60, minus 3 into 15 becomes 45, then minus 115, so 15, which is equal to 60 minus 60, which is equal to 0. So determinant value becomes 0. So next I'm going to check the another minor matrix. Here I'm going to choose the second column. So I'm going to choose the second column, and then remaining 3 columns I'm going to enter into 3 by 3 matrix. I'm going to consider the second 3 by 3 matrix. I'm going to give the symbol plus minus plus, which is equal to 3 times of determinant of -2, 4, -1, 2, then -1 of rows and columns will be eliminated. Then we get 1, -1, 7, 4, 2, here 7. Okay, then which is equal to next one -2, create cofactor, determinant value becomes -1, -1, -2, 7, -1, which is equal to, so 3 times of first diagonal minus second diagonal, -2 into 2 becomes -4, here minus into minus becomes plus 4, then -1 of first diagonal minus second diagonal, -1 into 2 becomes -2, then minus 7 4s are 28, -2 of minus into minus plus 1 becomes -7 2s are 14, -14, then it becomes plus 14, which is equal to 3 times of 0 plus 4 minus 4 becomes 0, then -1 of -2 minus 28 becomes -30, -2 times of 1 plus 14 becomes 15, which is equal to 3 times of 0 becomes 0, then minus into minus positive, 1 into 30 becomes 30, then minus 2 times of 15 becomes minus 2 times of becomes 0, 30, so we get 30 minus 30 becomes 0, the determinant value becomes 0. Next I'm going to choose the another 3 by 3 matrix. Next I'm going to choose the 3 by 3 matrix from the third column. So third column becomes 1 -2 -1, then fourth column -2 4 2, then first column cyclic order la edukano, so 4 -3 6. Next I'm going to give the symbol plus minus plus, which is equal to, so first row மட்டும் expand பண்ணிக்கிறோம். So 1 create determinant, rows and columns will be eliminated. Here 4 -3 2 6, then minus of -2 create cofactors, so determinant of rows and columns will be eliminated. So remaining entries -2 -1, then -3 6 -3 6, then plus 4 of the determinant value becomes, remaining rows and columns will be eliminated. So -2 -1, then 4 2, So the determinant value becomes 1 of, so first diagonal minus second diagonal, 6 fours are 24 minus 2 threes are 6, minus 6 becomes plus 6, minus minus becomes plus 2 of, minus 2 into 6 becomes minus 12, then minus of, minus 1 into minus 3 becomes plus 3, plus 4 of, first diagonal minus second diagonal, minus 2 into 2 becomes minus 4, minus of, minus 1 into 4 becomes minus 4, we are more plus 4, I know. Okay, then which is equal to 1 times of 24 plus 6 becomes 30, plus 2 times of minus 12 minus 3 becomes minus 15, plus 4 times of plus 4 minus 4 becomes 0, so which is equal to 30, plus into minus we get minus 2 times of 15 becomes 30, here 0, so final answer becomes 0, so the determinant becomes 0. So next I am going to check the another matrix. So now I am going to choose the fourth column, minus 2 4 2, then first column 4 minus 3 6, then second column 3 minus 1 7, so give the symbol plus minus plus, which is equal to, first to expand, minus 2 of the determinant rows and columns will be eliminated, so remaining entries minus 3 6, minus 1 7, then minus 4 of determinant rows and columns will be eliminated, here 4 2, here minus 1 7, then plus 3 Korea cofactors, 3 Korea rows and columns will be eliminated, so remaining entries 4 2 minus 3 6, so which is equal to minus 2 of first diagonal minus second diagonal, minus 3 into 7 becomes minus 21, minus of minus 1 into 6 becomes minus 6, here comes plus 6, so minus 4 of 7 fours are 28, minus 2 into minus 1 becomes minus 2, here comes plus 2, 3 times of 6 fours are 24, minus 2 6 are, sorry, 2 3s are 6, minus 6, here comes plus 6, which is equal to minus 2 of minus 21 plus 6 becomes minus 15, minus 4 of 28 plus 2 becomes plus 30, then plus 3 times of 24 plus 6 becomes plus 30, which is equal to minus into minus becomes plus 30, minus of 4 into 30 becomes minus 120, plus 3 into 30 becomes 90, so which is equal to 120 minus 120 is equal to 0. Therefore here all the 3 by 3 matrix, so determinant becomes 0, so therefore row of A is does not equal to 3. Next I am going to check the 2 by 2 matrix. So I am going to take the original A matrix. I am going to check in 2 by 2 matrix. So first 2 by 2 matrix becomes 4 3 minus 3 minus 1 is a minor matrix. First diagonal minus second diagonal becomes minus 4 minus of minus 3 into minus 3 3 becomes minus 9, which is equal to minus 4 plus 9, here we get plus 5, here the determinant value does not equal to 0, so over 2 by 2 minor matrix does not equal to 0, that means the entire determinant A does not equal to 0 in 2 by 2 matrix. Therefore the row of A matrix, which is equal to the order of matrix 2, is the rank of matrix.